On the graph at right, place and label a point for each of the products listed. So we've got Dog Eat Dog has a supreme hot dog that weighs 80 grams and has 40 grams of fat. So let's see, 80 grams. Other ones have 50 grams and 40 grams. So we'll make 80 grams all the way over here. 80 grams and 50 grams of fat. We'll make that up here. So this point right here would be Dog Eat Dog. Hot Doggies has a diet hot dog that weighs 50 grams and has only 9 grams of fat. So let's see, if this is 80, then right here halfway would be 40. So 50 would be about right there. And then we want 9 grams of fat. So if that's 50, then we go 40, 30, 20, 10. So that'd be right underneath 10 would be 9 grams of fat. So this is Hot Doggies. And then Dogalicious has a cheap hot dog that weighs 40 grams, so that's right here, and has 30 grams of fat. Right there. That's Dogalicious. Complete each sequence below. So let's see. First I see that we're adding, this is +2, +3, +4, so I'm assuming we'll go +5, which is 15, and then +6 is 21. So using words to describe how the patterns work. So I notice here that the second difference is constant. So each time the first difference increases by 1. So this is a quadratic because the second difference is constant. It's constant at +1. For B, I see that we're going from 1 to 1/2 to 1/4 to 1/8. I see that the bottom is doubling by 2. So each time we're multiplying times 1/2. Because 1/2 is half of 1, 1/4 is half of 2, 1/8 is half of 1/4. So then we're going to go 1/16 and 1/32. So here each time we're multiplying by 1/2. So this is an exponential because we're multiplying by a constant number. Here I see that we go times 3, times 3, times 3. So again, we'll do 27 times 3 is 81. And 81 times 3 is 243. So here each time we're multiplying by 3. And this one is also exponential because it's multiplying by a constant number. So here, let's see, -1, -2, -3. So we'll go -4. 2 minus 4 is -2, and then -6 is -8. Here, -1, -1, -1. Oh shoot, no, this should be -5, so that should be -7, -1. So D is also quadratic because the second difference is constant. At -1. So this is quadratic. And the first difference decreases by 1 each time. All right, let's see here. We go -2 plus 5 -2 plus 5. So I'm assuming that's the pattern. So we're going to go -2 is 53 plus 5 is 58. So here, this one is not anything that we know because it's going back and forth between adding and subtracting. So we could just, to describe it, we could just say first subtract 2, then add 5, then keep repeating the pattern. Alright, so here we got some diamond problems. So let's remember the pattern. We multiply to make the top and we add to make the bottom. So -9 times -5 is positive 45. -9 plus -5, so we're going to start at -9 and go to the left 5 spaces. So it's -14. Two numbers that add to make 7, and one of them is 9. So that would be -2. 9 times -2 is -18. Two numbers that add to make, or multiply to make 6 and add to make 5. 2 and 3. And then here, what number multiplies by 1/2 to get 4? So that'd be 8. 8 times 1/2 is 4. Sorry, we need it to add to make 4. So 3.5 plus 1/2 equals 4. So 3.5 plus 1/2 is 4. 1/2 times 3.5. So let's see, first let's make 3.5 into an improper fraction. So we've got 3 wholes, that's 6 halves. 3 wholes is 6 halves, plus 1/2 is 7 halves. So 1/2 times 7 halves is 7/4. All right, draw a sketch of a linear graph, an absolute value graph, an exponential graph, and a quadratic graph, and label each sketch. So a linear graph is a straight line. So it would just look like that. An absolute value graph is going to look like a V. An exponential graph starts off really flat and then curves steeply up. And then a quadratic graph is a parabola. So it looked like that. Susan's apartment is shown at right. Assuming that all rooms are rectangular, find the quantities described below. All measurements are in feet. So we want to find the area of her living room. So her living room is this box right here. And we know that from here to here is 18, and from here to here is 15. So the area of her living room is 18 times 15, which is 270. And let's see, we're in feet, so 270 feet squared. The area of her entire apartment would be this whole length right here, which is 10 plus 18, which is 28, times this length, 15 plus 8 is 23. So the area of her apartment is 28 times 23, 644 feet squared. How much larger than her bedroom is her living room? So first we have to find the area of her bedroom. So her bedroom is 10 by, let's see, this length right here is the same as 15. So the area of her bedroom is 10 times 15, which is 150 feet squared. So the area of her living room minus the area of her bedroom is going to give us the difference. So the area of her living room is 270 feet squared minus the area of her bedroom is 150 feet squared. So the difference, 270 minus 150, is 120.